Welcome to Immunopolis, the well-guarded city within our body. A city that never sleeps, because danger never rests. Towering walls made of intact skin shield its borders, reinforced by tightly joined epithelial cells and constant desquamation. Guarded gates of mucous membranes regulate every entry point, where mucus, ciliary motion, and continuous fluid flow prevent microbial attachment. Acidic environments, lysozyme, defensins, and a vigilant normal microbiota patrol the surface, halting most invaders before they even try. But when a breach occurs, the city responds instantly. Alarm signals echo through the streets as pattern recognition receptors on innate immune cells detect danger signals and trigger cytokine release. Neutrophils rush in like emergency responders, rapidly recruited from the bloodstream, short-lived, and ready to sacrifice. Macrophages stand firm in the tissues, engulfing intruders, releasing pro-inflammatory cytokines such as interleukins 1 and 6 and tumor necrosis factor alpha, and coordinating the defense while preparing the ground for repair. In response to released pro-inflammatory cytokines, blood vessels widen and get leaky. Endothelial cells express adhesion molecules. Reinforcements roll, activate, adhere, and transmigrate with precision. Inflammation is not chaos. It is a smart, targeted, and regulated strategy. Invaders are opsonized, tagged with the complement fragment C3b and immunoglobulin G, and pulled into phagosomes. Inside phagocytes, some are dissolved by lysosomal enzymes and defensins. Others are destroyed by the respiratory burst, using reactive oxygen and nitrogen species to ensure microbial death. When viruses attempt to hijack the city from within, distress signals are sent. Type 1 interferons alpha and beta warn neighboring cells, degrade viral RNA, block protein synthesis, and raise MHC class I expression on infected cells, thereby enhancing their visibility and accessibility to cytotoxic T lymphocyte recognition and killing. Some viruses down-regulate or abolish MHC class I expression on infected cells, rendering them invisible to cytotoxic T lymphocytes. In response, natural killer cells patrol the tissues, detecting missing self, and rapidly release perforin and granzymes to induce apoptosis, eliminating compromised cells before viral replication and spread can occur. Macrophages and natural killer cells form a rapid, tightly coordinated alliance that amplifies innate immunity. Macrophages are the first sentinels. Upon engulfing microbes, they release pro-inflammatory cytokines such as interleukins 12, 15, and 18, which serve as activation signals for nearby natural killer cells. Activated NK cells respond by secreting interferon gamma, a critical cytokine that enhances macrophage microbicidal activity. Together, macrophages and natural killer cells create a positive feedback loop. In innate immunity, there is no immunological memory and no recall response to rely on. Each encounter is met as if it were the first. Innate immunity acts immediately, driven not by specificity but by speed, coordination, and pre-programmed defense mechanisms. Its response is rapid, powerful, and relentless, designed to contain and eliminate threats within minutes to hours, buying critical time until the adaptive immune system can be mobilized.